Hi everyone. Today we will cover the topic of power steering system. Just the power part of the power steering system. The manual steering system we have talked in another video clip already. So we will just cover the power steering system. So the power steering system is basically the manual steering system. Adding some kind of power booster. So the power system is basically some kind of assist. So some kind of assist means there will be a system that help us turn the steering wheel. Which means that there is some system that add force when we turn the steering wheel. So it helps us, so it add force, apply some kind of force, so that we don't have to apply a lot of force on the steering wheels. This is the power steering system. So it has some kind of power booster, which is basically the typical system has the power cylinder, which is the hydraulic cylinder and piston, built into the steering gear. So we have a steering gear. So that is rack and pinion, and we add a cylinder there, connect to the steering gear, and then there is a hydraulic, right? The cylinder has hydraulic, so we use the hydraulic force, to push the wheel left and to push the wheel right. It cannot just push the wheel anytime it wants. It has to push the wheel. Help the driver push the wheel at the correct time that I want. That's the difficult part. So normally steering effort is applied using by the control valve, that admit the pressurized fluid into the cylinder. We'll talk about that. So basic part, because it is a hydraulic system. We need to build up a pressure in the hydraulic oil, right? We need the hydraulic oil. We need to have create pressure in the oil, and then we have to have a valve that open that pressurized fluid in the direction that we want. So first we need oil pump and reservoir, right? We have to create the pressure, and then we have high pressure line and hoses, the cable, the tube and the hose. We need the cylinder. We need valves. We need a control valve, and we need the return hose or return line. So what we need is we need a pump. We need the return line and pressure line. We need some kind of cylinder attached to the steering gear, and that's it. And we have a valve. Not in this picture. We also have a valve. So first we need the pump. The pump need power. Need to be driven by some kind of energy source or power source. So what power source that we have in the car? So we have engine. So if we have power steering, the hydraulic power steering, we need a power steering pump. And the power steering pump is driven by belt. From engine. In this picture, number 50 is a crankshaft. So this is the engine shaft. So we get power here, and then this power is used to drive many components. For example, we used to drive the air conditioning compressor. We drive the water pump. We drive the generator, which is the alternator. And one of that is PS pump. PS stands for power steering. Drive the power steering pump. So normally we use a belt to drive the pump. There are different types of the pump. Very similar design. Just different internal component. We can have a vane type. We have a slipper type. We have roller type. Because we use the liquid or the very viscous fluid with the oil inside. Therefore, it uses the positive displacement pump, which means that we create vacuum and suck in the oil, and then we push it out. Okay, we suck in and we push it out. So okay, we create volume here, and then we close that volume. Okay, we create volume, so we create vacuum and pull, suck in the oil, and then we close the volume, so we make the volume smaller, so we push the oil out like that. So we suck it in here, we push the oil out here, and we suck it in here, we push the oil out here, suck it in here, and push the oil out there. Okay, so these are the picture, the difference between roller and vane and slipper type. Okay, so they are very similar. Okay, that's the main part of the pump. Okay, the pump has like outer rotor, okay, they call it cam ring, okay, the inner rotor, and all this vane. Okay, all of this combine in the housing, and we have a pressure plate with spring in the back. Okay, where is the spring? With spring in the back, right? We have the pressure plate with spring on the back. So this spring controls the pressure inside the volume inside the pump. Okay, and then the shaft is connecting to, I believe, the pulley, okay, from the belt from the engine. Okay, and then we have end cover there, and we put everything together with the reservoir. Okay, this design is, I saw it in I think European car. Okay, Mercedes-Benz using the old Mercedes-Benz use this design. Okay, sometimes we have a separate reservoir and the pump in a Japanese car. Okay, now this pump is run by the engine, right? So it connects with belt from the engine. Okay, so the RPM, okay, the speed of the pump follow the speed of the engines, and the speed of the engines depend on the driver. Okay, whether she accelerate or whether she like driving cruising at cruising speed. Okay, so the speed of the pump we cannot really control. Okay, it's just depend on the engine. So sometimes it create too much flow, sometimes it create less flow. Okay, so we design it such that it create enough flow at low RPM, right? At low RPM, because normally we want assist, okay, at low engine RPM. Okay, now when engine RPM is increasing, the pump create more flow. Therefore, okay, we cannot let that flow go out, otherwise it will create a lot of leaks, okay, at seals and many locations. Therefore, at the exit of the pump, okay, we will have this control valve. Okay, this control valve, okay, is used to control the flow, okay, or the pressure. Okay, it's called flow control valve. Okay, this is just a control valve in the pump. Okay, basically at high speed, okay, pump flow too much fluid, and there will be a valve or bypass port, okay, that let the flow that is going out from the pump feed back to inlet of the pump. Okay, the flow that flow out, okay, we take some part and give it back to the inlet, okay, to prevent too much flow in the system. Okay, so therefore, this is inlet intake is yellow, discharge is like green. So inlet here and inlet here and discharge here, inlet here and discharge here. So discharge combine here, and there is this valve, the metering valve. Okay, and this valve is controlled by this spring. If the exit pressure is too much, it's let the flow that going out or go back to the inlet of the pump. Okay, so we have this flow control valve at the exit of the pump. Okay, coming out from the pump, okay, the hydraulic fluid go to this pressure hose. Okay, and return hose. Okay, return is for going back. Okay, so the going out is the pressure hose. Okay, pressure hose, okay, have a lot of pressure inside. Okay, first thing. Okay, and another thing for the power steering system is that this hose always flex. It's stretching and it's flexing all the time, because we need power very short time and then we stop the power, right? So when we turn the steering wheel, we need power, so the hydraulic pressure go out, okay, it push out, and then after we stop steering wheel, the hydraulic pressure stop. So the pressures move inside, back and forth inside the pressure hose, right? So it always do flexing and stretching, okay? So it has to be very strong. Normally we cannot just use rubber hose. We use steel braided hose, okay? In Thai เราเรียกท่อถัก okay เป็นท่อถัก okay there are still, how do you call it, steel wire on the outer side of the hose, okay, such to make it stronger, to make it to be able to withstand the flexing or the stretching, the continuous stretching of the hose. Okay, the return is, I mean, it contains less pressure, so it's not really critical for the return hose, but for the pressure hose. Okay, and at the end of the pressure hose, okay, normally we use some kind of fitting, okay, jump on the hose like that. Okay, it's a fitting that fit on the hose. Okay, we cannot just like use rubber hose and use like how do you call it, a belt, a little belt, okay, that fit the hose on the pump. Okay, we need some kind of special fitting at the end of the hose. Okay, so that's pressure hose. Okay, now getting out from the pressure hose, okay, we already have hydraulic pressure. Okay, we will send that hydraulic pressure to the power cylinder or power booster, okay, that connect to the steering gear, right? So we will talk about the rack and pinion steering gear first. Okay, this is a rack and pinion power steering. Okay, rack and pinion power steering. So we have rack and pinion. Okay, we have the steering column, and then we have the steering gear here. Okay, and we have rack and pinion. Okay, now we add the power part of the system. So we need pump, we need hose. Okay, the hydraulic hose will go into this guy. In here, it used to be a steering gear. Now we add more component in there. Okay, so inside here, instead of just pinion and rack, okay, we will have this control valve also. This is not flow control valve. This is a steering control valve. Okay, this is a control valve that control the assist. Okay, here. So the hydraulic pressure go in. Okay, the valve control the direction of the hydraulic pressure. Okay, and the pressure go out this tube and this tube. Okay, onto this power cylinder. So it will send pressure to this power cylinder. Let's look inside. Okay, inside. Okay, remember we have pinion and rack. So there is a rack here. Now we add the piston here. Okay, we add a cylinder and we have a piston, and we connect that piston to the rack. So now we have a rack, the pinion running on the rack, and this rack connect to the piston also. So if we can push this piston, it will push the rack also. So it will assist our effort, okay, to turn the car, okay, to turn the wheels. Okay, so if we want to turn left, okay, the upper picture is turn left. Okay, the hydraulic pressure that coming from the valve will go into this tube, go there, go there, go there, and go there, and push the piston this way. Okay, push the piston this way. On the other side, okay, it is a hydraulic fluid. Okay, there is the hydraulic fluid, which doesn't have a lot of pressure. Okay, because it is not the pump side. Okay, it's not on the supply side. It's the return side. Okay, this fluid, okay, will be pushed out by the piston, and then it go out this way, go out this tube, go to the valve. Okay, and it will go back to the pump. Okay, this is the hydraulic fluid from the pump. This is going back to the pump. Okay, if we want to turn right, the control valve will open another way. Okay, it will open another how do you call, another passage. Okay, so instead of sending pressure to this tube, it will send pressure to this tube. Go in and push the rack this way. Okay, the return one will go this tube. Okay, we go into this tube and go back to control valve and go back to the pump. Okay, this is how it works. Okay, you just add the cylinder there, and you have to be able to control the pressure fluid. Okay, the fluid. Hey, now this diagram, okay, show the operation of the power steering. Okay, the hydraulic system. Okay, we have a reservoir, we have a pump. Okay, normally if we are in neutral positions, okay, with for example a straight line, okay, if we go into the straight line, okay, the pressure from the pump going out, and we have flow control valve here that return the flow into the inlet, right? So passing that flow control valve, okay, it go into this another control valve, okay, the main control valve, okay, the one that we talk about. Okay, normally at neutral positions, okay, the control valve is in the middle like that. Okay, the fluid flow, okay, instead of flowing into the cylinder like this, or on the left or on the right, okay, it just passed through. It passed through the control valve and return back to the pump. So the pump the fluid, okay, and let it return back like this. So the fluid keeps circulating like that in neutral position. So if we do not turn the steering wheel, it will just circulate like that. Okay, now if we turn the steering wheel, if we want to go right, okay, let's say if we want to go right like that, okay, the control valve will change, okay, will twist a little bit, okay, it will change position like this. So it will block the pressurized fluid, okay, and then let it go to this side of the cylinder, okay, this side, okay, this side of the power cylinder, which push the piston there, or which push the rack onto this way. The return fluid, okay, we go to the control valve, and then the control valve will block the return fluid such that it flow back to the pump like that. Okay, so this is only for during a steering wheel turn. Okay, when we turn the steering wheel. So after we turn the steering wheel and we hold it, okay, after we turn and we hold it, so we don't do at this position, we do not need assist anymore, right? If there is assist, we have to resist back, right? So if there is assist, we have to resist. Does not work. So if we stop the steering wheel, okay, it has to go back to the neutral position. Okay, so it says here that when the steering wheel has been turned and held in positions, okay, the control valve will have to return to the neutral positions. So this happens only when we turn the steering wheel. Okay, now because this pump use power from engine, okay, so when the control valve open like this, and the pressure will be blocked, right? The pressure will be blocked, and the pressure will be sent to the wheels, the steering wheels, okay, the rack and pinion, the steering gear, and the steering gear and the wheels, okay, the car wheels. Okay, the pressure will build up in this side of the control valve. Okay, when the pressure build up, okay, the pump will consume more power. Okay, when the pump consume more power, the engine power will drop. Okay, now in order to keep engine running, okay, for example at idle, okay, we need this air control valve. This air control valve will detect the pressure inside the system, and then it will order more air. It will open more air into the engines. Okay, this is the engine air. It will open more air into the engine such that engine has more power, because the pump take a lot of power. Okay, the steering pump take a lot of power. Okay, so we have to make engine run at higher level. So we have to add more air into the engine. Okay, so that's the function of air control valve. Now, go back to this control valve. Okay, the steering control valve. Okay, how can it detect when we turn the steering wheel? It will have to like operate only when we turn the steering wheel, right? Okay, to do that, inside the control valve, okay, they use a spool valve. Okay, spool valve or rotary valve is a valve that has two sleeves like this. One sleeve inside, one sleeve outside. Okay, there is probably a flow, the flow in. Okay, the inlet is outside, the outlet is inside like that. So there is a valve like this. Okay, the supply is outside. Okay, it go past the valve and it go out like this. Okay, so this is a spool valve. This spool valve connect to a torsion bar. Okay, there is a torsion bar connect to the spool valve. So there are two sleeves. One sleeve connect to one side of the torsion bar. Another sleeve connect to the another side of the torsion bar. Okay, the torsion bar means the bar that can twist, right? Okay, so this operation of spool valve depending on the twist of the torsion bar. Okay, so if we look at this in this picture, okay, this is a rack, this is a pinion. The pinion connect to one side of the torsion bar. Okay, number one is torsion bar. Okay, another side of the torsion bar, another end of the torsion bar connect to the steering column. Okay, or the steering wheels. Now, if we turn the steering wheel and there is some kind of resistive force, okay, resisting force that probably come from the wheels. Okay, if there is a resist force coming from the wheels, it come to the rack, it come to the pinion. So if we turn the steering wheel, the torsion bar will twist. It will twist a little bit, and that action will move the spool valve. Okay, we'll open the spool valve. Okay, if we cut across, okay, if we let's look at the pipe first. Okay, there is a pipe connecting to the control valve. Okay, number 5, 6, 7, 8. Okay, 5 is a pressure pipe from the pump. 6 is oil return pipe. 7 is oil pipe to the right turn. 8 is for left turn. So what we have connection to this valve is that there is a pressure from the pump, there is a return to the pump, there is left turn, there is right turn. Okay, this go to the right, left turn, this go to the right turn like that. Okay, now go back to the torsion bar. Okay, when the torsion bar twists, the spool valve move. Right? So if it not twist, the spool valve will be at the center. Okay, when it moves, the spool valve will move. Okay, the spool valve has two, let's say, two sleeve. Okay, there is an inner sleeve, the blue one. Okay, there is an outer sleeve, the white one. Okay, the pressure from the pump, okay, I believe is come from the outside. Okay, come here. This is the pressurized fluid from the pump. Okay, and the return to the pump is here. This is coming from the pump, this is return to the pump. This go to the left turn. Okay, this go to the right turn. Okay, so if the torsion bar twists, okay, the two sleeve in the valve, okay, will do this. So the valve or the inner sleeve will close this passage. Okay, will close this passage. So now, what happened is that, okay, the pressurized fluid, instead of going this way and that way, it will go only on this way. So it will go to the left turn. Okay, it will push the rack going to the left, and then the return on another side of the cylinder. Okay, let's say this is a cylinder. Okay, we have a piston there, we have a rod here. Okay, and then this left turn go there. Okay, on the right turn it will go back here. And then we go back because the valve block this process, right? So the return will go there, go back here, and then you go here, and return to the pump. So the pressurized fluid will go to the left turn. Okay, the return fluid will go to back to the pump, like that. So this is for turn left. Okay, if we turn right, the torsion bar will twist another way okay, will twist another way, so it will let the fluid go to the right turn instead, and the return coming from the left will go to the pump. Okay, we go back to the pump. Okay, so that's how it works. So that's for rack and pinion. Okay, for recirculating ball, okay, or for the steering ball, steering gear, okay, we also have a cylinder. Okay, and the cylinder, okay, is inside the steering gear. Okay, let's talk about that. Okay, now remember that, okay, for the steering gear, for the recirculating ball steering gear, okay, we have this kind of this gearbox. Okay, this side is connect to the steering wheel. Okay, this connect to the steering wheel, and this is the pitman arm. Okay, this connect to the pitman arm, and then it's connect to the center link, connect to the tie rod, and connect to the wheels. Okay, the car wheels. Okay, that's the wheels. That's the steering wheels. Okay, now we put the spool valve here together with the torsion bar. Okay, the spool valve is here, the control valve is here together with the torsion bar things. And we put it here. Therefore, when the driver turns the steering wheel, if there is a resistive force from this side, okay, the torsion bar will twist, okay, and the valve will operate. Okay, now in this system, okay, what we have is that, okay, we have to have some place to put our piston, the cylinder, the power cylinder and piston, right? So the best place is the nut. Okay, remember that we have a worm gear, and we have the nut, and we have the sector gear, right? The worm gear drives the nut drives the sector gear. Okay, the worm gear drives the nut drives the sector gear. Okay, now because the nut is moving in the linear motions, therefore we can put the piston connecting to the nut. Okay, we connect the piston to the nut. Therefore, now inside the steering gearbox, okay, the nut is cover the worm gears, and then it creates a cylinder with the volume on this side and volume on this side, like that. Okay, so let's see. If vehicle is going straight, okay, the pressure from the pump, okay, instead of going into the cylinder, it will just flow back to the return. Just doing that. Just circulate like that. Okay, it consumes power, but we need to do that. Okay, so the spool valve is in the middle. Okay, it's in the middle. The pressure on the two sides of the cylinder, I mean, they are the same. So there is no assist. Okay, now if we want to turn left, okay, the pressure will, I mean, the spool valve will move. Okay, the pressure, instead of going back, the pressure will go this way, pushing the piston or pushing the nut this way. The return fluid here will go here along this tube, going to the control valve, okay, this guy, and then go return to the pump. Okay, this is for left turn. Okay, for right turn will be reverse. Okay, the pressure, instead of going in here, the pressure will go out there along this tube. Okay, push the piston or push the nut. Okay, the nut will move this way, the wheel will turn, and then the return on another side will go back to the valve, and the valve will send it back to the pump, like that. Okay, so that's it. Okay, now that's the operation of the power steering. Okay, now if we talk about the assist force, okay, the assist force, okay, how much we want it to assist. Okay, normally, okay, if the car move at slow speed, we need a lot of force to turn because there are a lot of friction, so the wheel do not turn, right? So the wheel do not spinning. So if the wheel do not spinning, let's say if we park the car and we turn the steering wheels, okay, there will be a lot of friction. So we need a lot of assist. However, if we drive at high speed, okay, the wheel is already spinning, so it's not difficult to turn. So there is less resistance. Okay, so we need less assist from the power steering. So if we use the same power pump, power steering pump, it creates the same pressure. Okay, it means that we have the same assist. Therefore, when we drive fast, okay, the wheel will be very, how do you call it, very soft. Okay, like that. So which is not safe. Okay, if we drive fast, the wheel has to be a little bit harder to turn, right? So the assist should be less. Okay, it should be a lot of assisting force. Okay, therefore in the car, okay, we need to have variable assist power steering. Okay, to variable assist mean, okay, to have for new car. Okay, so the assisting force on the steering will be more if the speed of the car is low. If the speed of the car is high, okay, we have to reduce the assist. Okay, so in order to control how much force acting on the steering or the power steering, okay, we have to control the pressure outlet of the pump, right? The pressure that go into the system, we have to control that pressure. In this system, we have this solenoid valve. Okay, try to open and close the hydraulic pressure here, and the valve is controlled by the ECU, and the ECU get the signal from, let's say, steering angle, the vehicle speed, and the engine speed. So we get signal from that, calculate in the ECU, and control this valve to control the pressure inside the system. Okay, in that case, we can control the amount of assist, okay, the force that assists when turning the steering wheel. Okay. Now, as you can imagine, okay, the power steering system take a lot of power from the engine. Okay, we have to create pressure, and then we let the pressure go back to the pump like that. So we have to create pressure because we have to wait. Okay, because we don't know when the driver will turn the steering wheel, so we have to always create pressure just to be ready for assist. Okay, that take a lot of power from the engine. Now, if it connect with the engine using belt, okay, another problem arises because of engine runs at different RPM. So most of the time we run the pump too much, so it takes too much power. So we want to separate the power steering pump from the engines. Okay, one way is to use electro-hydraulic power steering. So instead of running the pump with the engine, okay, we're running pump using electric motor. So we have an electric motor driving the pump. Okay, now we use electric now, so we do not connect engine to the pump. Okay, so we can control the speed of the pump using electronic. Okay, using electric. So that's easier. We can control at constant speed. We do not have to depend on the engine, right? So this will reduce the pressure. Reduce the power usage in the power steering system. Okay, so this is one way. Okay, we still use hydraulic power steering, but we run the pump with electric. Okay, so that's why we call electro-hydraulic power steering. Okay, now if we still use hydraulic, okay, there is another problem. Okay, that problem is that hydraulic tends to leak. There are a lot of components, there are a lot of locations that can leak, okay, that the fluid can leak. A lot of seal, a lot of hose, a lot of rubber, So many places can leak, even inside the cylinder, even inside the piston. Okay, there is some leak. Okay, that's a big problem. Okay, a lot of component and there's leak. The good thing about hydraulic is that it creates a lot of force. Okay, it creates a lot of force, and that force is very quick, very rapid. Okay, now because of the advancement in motor technologies, okay, we can create a motor, electric motor that create a lot of force. Okay, that can create a lot of force in a short time. Okay, therefore, most of the new car, instead of using hydraulic power steering, okay, it use electric power steering. In this case, we don't have hydraulic anymore. We don't have power steering pump. We don't have power steering fluid anymore. Okay, so you have this electric power steering. Okay, normally they use EPS. Okay, stand for electric power steering. So instead of hydraulic, okay, we put a motor in there. Okay, this is armature and fuel coil is the main component of motor. Okay, we put a motor in there that drives the rack like that. Okay, so we control this motor using electric. Okay, using the ECU and control it there. So when the driver turn left and right, we can control this. So in order to know whether the driver turn left or right, or when the driver turn the steering wheel, okay, so we have to put torque sensor there. Okay, we used to have a torsion bar, right, in the hydraulic system. Okay, now instead of torsion bar, we have to put torque sensor there. And this torque sensor send the signal, send the information to the ECU, and the ECU figure out the meaning of that, and then it control the motor here. Okay, this is a kind of step motor or fast acting electric motors. Okay, most of the new car, okay, the small car, most of the passenger car use electric power steering. It uses less power. Okay, it is more compact. Okay, it has less component, therefore we have less maintenance. Okay, however, it cannot be used in a very heavy car, because the power from motor is not the same. Okay, it cannot as high as force from hydraulic. Okay, so this is a new trend. Okay, electric power steering. Okay, so the next thing that I want to talk about in the steering system is, okay, there is some cars, okay, that instead of using only front wheels to turn, okay, normally we use front wheels only to turn, right, left and right. Okay, they use four wheels. Okay, they also use rear wheels for steering. Okay, we call this type of car four-wheel steering. Okay, as you can see, okay, the rear wheel also turn. It can turn in the same directions. It can turn in the opposite directions. Okay, so this can improve the motion of the car. Okay, for example, for normal car, we fix the rear wheels, right? We only turn the front wheel. So if we want to change the lane, okay, change the traffic lane, okay, when we want to change the lane, okay, we have to turn the front wheels, and then the car have to rotate, right? So it will have the angular velocity. Okay, the car will have angular velocity to the right, and then after we go to that lane, okay, we have to turn back, so there will be another angular velocity. So you have to go right and go left like that, angular velocity. So this motion is people can detect, the passenger can detect. Okay, it might be, I mean, nicer, okay, if the car can just slide to another lane, right, instead of like turn to another lane like this. Okay, would it be better if it can slide to the next lane? It will be quicker, it creates less angular movement, okay, which means it will be safer, it will be nicer to ride on the car, right? But if you want to do that, the rear wheel has to turn also, so it will improve when you change the lane, right? So that's one reason. Another reason is that, okay, normally the rear wheel is fixed, so we turn the front wheel. So if we want to make a U-turn, okay, the turn radius, okay, has to be large because the rear wheel is fixed. So that's why we have to turn around, making a U-turn. Okay, so it's not really very efficient, okay, when we do a U-turn. Okay, normally if we want you to turn, we can do turn in a very tight curve. It would be better, right? So if we can turn the rear wheels also, okay, if we turn the front wheel to the right, we turn the rear wheel to the left, okay, we can make a U-turn faster. That's good, right? So the 4-wheel steering system, okay, also can do the same direction turns, okay, the same direction turns and the opposite direction turn. Okay, this for changing lanes, okay, this for making a U-turn or making a corner like that. Okay. Okay. Normally, okay, when we change lane, okay, normally we are doing that at high speed. So high speed, okay, when the car is at high speed, okay, the rear wheel will turn in the same directions. Okay, at low speed, it will turn in the opposite directions, like that. Okay, some car has that. I believe Tesla have that. Okay, Tesla car, the electric car, the EV, okay, have 4-wheel steering. Okay, so it might be the future of the car. Okay, now, how much the rear wheels can turn? Okay, if we look at this, okay, our normal cars, if you want to get out from parking like this, okay, the parking parallel to the in Thai we call footpath, right? Okay, to the normally in US we call curb, okay, parallel to the curb. Okay, if we use typical car, okay, we can go out very easy, okay, because the center of the turning is there. Now, if we turn in the same direction like this, okay, the problem arises because we cannot get out because we will hit the car in the front. Okay, if we turn in the opposite direction, okay, the rear will turn in the opposite directions. Okay, the problem is that, okay, the rear of the car will hit the curb. Okay, so that's not really practical, right? So, okay, therefore the rear wheel cannot turn too much because otherwise it will not be practical in this case. Okay, therefore normally, okay, for the opposite direction turns, the rear wheel only turn about 5 to 6 degrees as compared to the front wheel turning at about 30 degrees, right? So the rear wheel only turn 5 to 6 degrees for the opposite directions. For the same directions, okay, it is limited to about 1 and 1.5 degree, very small. Okay, this is a very limit, so it helps a little bit, it cannot help a lot because we cannot allow it to turn too much. Okay, so that's the limit of 4-wheel steering. Okay, now the first company, okay, that developed the 4-wheel steering is this company. Okay, it is Honda. Many years ago, 20 years I think. Okay, so they start first with the mechanical 4-wheel steering. Okay, they have like a shaft sending motion from the front wheel steering. Okay, from front wheel steering, okay, sending that motion to the rear wheels. And at the rear wheel they have this gearbox, okay, to control the turning of the rear wheels. Okay, in this gearbox they have this kind of mechanism. Okay, you can go back and try to analyze it. Okay, from the center shaft, it goes here and go to this pinion, go to this, match to this ring gear, and this pinion, okay, connect to this slider and connect to the rear wheels. Okay, very complex mechanical design. Okay, however, the result is that, okay, comparing to the front wheel turn, okay, we turn from 0 to 30 degrees. If we turn a little bit, okay, the rear wheel will turn the same direction, right? The positive directions. If we turn to the positive directions, okay, now if we turn more and more, okay, the rear wheel will go back to 0. Okay, it will go back to 0, which means going straight. And then after that, it will go to the negative direction. So it means it will go to the opposite directions. Okay, as we turn more and more, it will go into opposite direction more and more. So this is how, this is the result of that mechanism. Okay, the Honda mechanism at the rear. Okay. So we also have rear wheel steering, which is hydraulic system. Okay, this is the rear hydraulic. So basically, it is similar to power steering. They use hydraulic to control. Okay, it has a shaft connecting the front and the rear also, and that shaft used to control some kind of valve. Okay, some kind of valve inside here. Okay, I don't actually know how it works. Okay, but it controls the valves here, and the valves control the hydraulic fluid, okay, to the power center on the rear. Okay, and then we have electronic rear wheel steering. So we use a motor, okay, because it's electric power steering, right? We have a motor inside, so there is no connection between the front and rear steering now. It is connected by electrical wiring. Okay, it's connecting by the signal, using the signal. It's sent to the ECU, and then it control the rear motor like this. Okay, so there is like hydraulic rear wheel steering. There is also electric rear wheel steering. Okay, so that's okay, all the material that I want to talk about in power steering system. Okay, so that's it okay, for this video clip. Okay, if you have any questions, okay, leave the questions below in the comment below, and then I will answer that, okay, in the comment. Okay, so see you.